Okay, well, let's see. If we're going to work out the surface area of the pond, what have we got, guys? We've got two big semicircles, each with a radius of big R. But that's really like one circle if you think about it. Then we've got the two little ones that are identical, and they've got a little r for their radius. So what we could then say in A, now watch this, is we could say that the surface area would be pi big R squared for the two semicircles that are fairly big, plus pi little r squared, okay, for the two little ones. So that's the total surface area. But when you want to now get a derivative, you want to now work with one variable. Now we don't, it's like having like big R as y and little r as x. We don't want that. We want to get rid of, maybe let's get rid of the big R. Now what do you know about what you've got here? You've got big R plus little r is fixed at 200. So big R would be then fixed at 200 minus r. Okay, now all you need to do is you go into this. Okay, so you can say, okay, A in terms of r, little r, would be pi r squared. So you replace the big R by this guy, and then we've got the little pi r squared over here that stays. Okay, now we've got the surface area in terms of little r. So let's multiply that out and see what we get. 200 squared, well, that's 40,000. Okay, multiply these two. 200 times r is 200r doubled is, of course, minus 400r. And then square the negative r, so you get that. And then we're left with the plus pi r squared over there. Okay, so the area in terms of r would be, now let's multiply this out like that and see what we get. That's going to be 40,000 pi minus 400 pi r plus, we've got pi r squared for this, pi times r squared, and then we still got the little pi r squared on the end there. Collect the like terms and let's see what we have. Little ar is equal to 40,000 pi minus 400 pi r plus 2 pi r squared. These two are like. And now let's differentiate those. Let's get the derivative. A prime little r. So that's constant, so it vanishes. That's naught. This one, treat the little r as an x, so it's just the remaining 400 pi. And then this one is easy. That goes to 2, goes down, multiplies with a 2, 4 pi r to the 1. Put the derivative equal to naught, and let's solve for little r and see what we get. Okay, there we go. So this gives me 400 pi is 4 pi r. Divide everybody by the 4 pi, and we've got, that gives you 100 is little r. So the little radius must be 100. So if we go up to there, let's go back to our circle. The little r here must be 100. And what would then the big R have to be as well? Okay, in other words, the big R would have to be as well. If we think about it, you've got big R is going to be the 200 minus the little r, which is 100 meters or whatever you working in. But now careful, it's 100 and 100 there. So the radius is, so it's almost, if you think about it, very interesting what that would look like if they would be pretty much equal. So kind of it would be very interesting. It would almost be like a full circle. But I'm not going to worry about the geometry of that. It's just to remember that you're minimizing that surface area, and if r is 100 and big R is 100, you get that. Now stay with us, because in the next lesson we're going to pursue 3 dimensions.